How to name type 3 molecular compounds. Things that start with a non-metal. Anything to the right of the little staircase. First thing you're going to have to do is you're going to have to memorize a list of prefixes. Prefixes that are associated with numbers 1 through 10. And many of them you already know. A few of them you might not. The first one, the prefix that we associate with the number 1 is mono, as in monotheism, monocot, monogamy. All these things deal with ones. That's the prefix for 1. 2 is di. You're probably fairly familiar with that one. And tree, try, tri. Maybe let's try getting these a little bit bigger, a little bit easier to see here. There we go. 1 is mono, 2 is di, 3 is tri, 4 is tetra, as in tetrahedron, or the game Tetris. 5. After 4, from 5 on, they'll become very familiar. They're just like your geometry polygons. A 5-sided one is called a pentagon, so the prefix is penta. For 6, it is hexa. 7 is hepta. 8 is octa. And 9 is nona. 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 And for 10, it's deca. So those are your 10 prefixes. Once you have those, you can begin to know how to write the names. So, what we're going to do is we're going to learn a little acronym that's going to help us to remember the rules here. The acronym is PEPI, P-E-P-I, and so we're going to see, make it nice and big so you can see it. We're going to see how to use the term PEPI to help us remember how to name type 3s. The first step is that P word, that first P. We're going to start out by writing the prefix associated with the first subscript. This is assuming that you have a formula and you want to write a name. The first element's going to have a prefix. You write the, it's going to have a subscript, and you're going to write the prefix associated with that. We'll do an example here in a second. The only time you don't do this is if the first prefix is mono. We don't start with mono. I've never had mono, but those people who have had mono told me that it's really bad. It's a really bad way to start the day. So never start the day with mono because it makes for a long day. And so that's just a little way to remember, never start with mono. So any name should not start with mono at the very beginning. But otherwise, we're going to start with the prefix associated with the first subscript. Next, we're going to write the name of the first. Now we got the P as the first prefix, and the second is element. Write the name of the first element in the formula. Next, we're going to, so we got the first prefix, the element, and then we go to the next prefix. Write the prefix associated with the second subscript next, even if it is mono. We can put mono in the middle. The last thing is we write the, what is this, I? So we got the prefix, element, prefix, and the last part is we're going to write the name of the second ion in the formula. Second one is an ion name. As you know, for these are all going to be non-metals, so they must make negatives, and these are all going to end with the IDE suffix. So prefix, element, prefix, ion. That's how we do it. So that's all you do. You just blindly follow whatever that will give you. You don't need to worry about charges. You don't ever look at charges. And so actually, I'm jumping ahead. Oh, I guess we're starting with a name, so there wouldn't be any need for charges. So let's do the example. So the example that we'll do, the classic example that everyone probably already could do, is CO2. So we go PEPI, 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 PEPI. Start with the first prefix. We start with the prefix associated with that first subscript. It doesn't have a subscript. If it doesn't have a subscript, then we know that it's really a 1. It's an understood 1. So we would start with mono. Oh wait, we'd never start with mono. We don't start with mono, so we'll just leave that off. So we'll skip that first part. Prefix, mono, skip it. Element, that element is carbon. And then we go to the second prefix. In other words, the second element, it has a subscript 2, and the prefix associated with 2 is di. And then the last part we name the ion on the end. Don't look at any subscripts or anything. You already took care of the subscript there. So just look at that. That's an ion. It's oxide. And so we end up with carbon dioxide, which is probably what you already knew the answer was going to be. And now you can see how we get that. Now, what about, let's try a different one now. Excuse me. Should have got the white screen here, but I didn't. Oh well. So let's do a different one. Let's go with BR for 07. Not sure if that exists. I'm guessing it doesn't, but that's okay. We can still name it whether it exists or not. PEPI, PEPI. Prefix, element, prefix, ion. So the first prefix goes with that. Prefix for 4 is Tetra. Element name. So do we say bromine or bromide? Those are our choices. Well, the first one is element. It's bromine. Tetrabromine. Then the second prefix comes next. Tetrabromine. That's 7. What is the prefix for 7? It's hepta. And lastly we have that element is oxide. Heptaoxide. Now if you wrote this down you'd get full credit, but one thing I didn't mention in the notes is these little kind of awkward double vowel sounds in the end of prefix. If you start in with a prefix and start with O, we generally will chop off that A, so we would say tetrabromine heptoxide. But that's not a requirement, that's just kind of how we do it. I'm not going to dock you for that. Now if we're going the other way, well, if we're going the other way, in other words, if we have the formula already, then we want to write the name. So we're going to do exactly the same thing, only backwards. We're going to use the PEPI rules backwards. Instead of turning the subscripts into prefixes, the prefixes are turned into subscripts. Don't overthink it. Don't even look at any charges. Never look at a charge. Use the element symbols, and then, I guess I just said this a second ago, you don't ever look at charges or try to balance them for type 3. This is only done for the other types. Type 3 is special. You don't have to know any charges at all to do a type 3. So let's do a couple of examples of type 3s where we have names and we want to write formulas. Well, how's about carbon tetrachloride? We'll do carbon tetrachloride. And how about trisulfur decanitride. Okay, let's try sulfur decanitride. So let's do those. The first example here, carbon tetrachloride. We go prefix, element, prefix, ion. So we look at the first prefix, and there isn't one, which means it must have been a mono, which means that we're going to start with, I guess this is, PEPI is really for naming. We can kind of figure out, going backwards, we can figure out the formula from the name. So we know that carbon had no prefix, which means it must be a 1, so the carbon must have a 1, but we don't write 1s. It's an understood thing. Tetrachloride means that the next thing that comes is chloride, and there are how many of them? Well, there are 4 of them. We're done. Don't look at charges. You're done. Same thing here. Sulfur, what's that? That's an element, symbol S. Tri means there are 3 of them, subscript 3. Nitride, that's N, and deca is 10. We're done. These are the easiest things in the world if you don't make them hard. These are, when people start throwing in charges and doing weird things with type 3s, they get hard, but these should be rather easy. That should be it.